Assalamu alaikum. Today we are going to give our presentation on the concept map of spelling correction and the noisy channel model. There are two kinds of spelling correction. One is non-word spelling correction and the other one is real word spelling correction. I'm Salil Arifin Rafi. In this presentation, I'm going to talk about non-word spelling correction. For this, we use the noisy channel model. The intuition of the noisy channel model is to treat the misspelled word as if a correctly spelled word has been distorted by being pressed through a noisy communication channel. The noisy channel model is a kind of Bayesian interference. Given an observation X of some misspelling some word, we would like to find W, the correct word. We are going to use the Bayes rule to find the maximum probability to replace the misspelled word X. For generating the candidates to replace the misspelled word, we can pick either of two options. One is words with similar spelling and the other is words with similar pronunciation. Here we are going to use the words with similar edit distance to error or pronunciation to error respectively. For the next part, we have to use edit distance algorithm where the edit are insertion, deletion, substitution, and for spelling correction operation we have to add transposition operation. Now the next parts will be presented by SK Safwan.
Thank you, Sadul Arfin Rafi, for handing over me the floor. Now I'm going to talk about the language model. For ranking the candidates, we are going to use a language model. We can use any of the language model algorithms like unigram, bigram, trigram for smaller tasks. For computing the channel model probability, assume that misspelled word X has a set of letters X1 through XM and the correct word W has a set of letters W1 to WN. Now the probability of the edit X given W is going to be some set of deletions or insertions or substitutions or transposition. Some set of edits, the way we are going to model that, we are going to create a confusion matrix, and a confusion matrix M says for any given pair of letters how likely is a particular edit to happen. Unfortunately, the channel probability model sometimes creates the wrong word. For this, we will use the bigram model. It finds a probability of the suggested words given the context or the previous or preceding word. So this is how the bigram model correctly picks the suitable words. Thank you.
The noisy channel approach can also be applied to detect and correct real-word spelling error. The real-word spelling error is very similar to what we did for the non-real words. We are going to generate a candidate set that includes the word itself and all single letter edits that produce English words. And given this candidate set for each word, we will choose the best candidates using the noisy channel model. Given a sentence with the word 1 through word n, we are going to generate for each word a set of candidates. So for word 1, we have the candidates word 1 itself and then a bunch of variants, the single edit distance neighbors of that word, and choose the sequence that maximizes the probability. Each sentence is scored by the noisy channel, which uses Bayesian interference. It will go through all the process of the noisy channel model and rank the suggested word. This is how the real word spelling correction works. Thank you.